Okay, so yesterday we talked about the idea that about how to convert from grams from mass of something to moles of something, or from moles of something to mass of something, or we converted from atoms to moles or moles to atoms. And I'd kind of like to take a minute or so to review what we talked about. And so, in that regard, we would say we might say that we had that 6.02 times 10 to the 23rd atoms of anything would be equal to 1 mole of that anything. We could also say that the average atomic mass of something on the periodic table would be equal to 1 mole of that something on the periodic table. So those were the two big things that we, not big things, but those are the two things that you kind of needed to keep in mind as you were going ahead and doing problems or practice problems yesterday. And I'm going to write periodic table down here as a reminder. Now, what hopefully you will be able to see, or at least you can identify, is that the one thing that's in common in both of these relationships is they both happen to equal 1 mole. Which means that 1 mole is like the door or the bridge or the thing that connects atoms and grams together, because we kind of discussed yesterday that technically speaking we don't measure anything in atoms, and we also don't measure anything in moles, but the mole allows us to measure, to collect data on something that we can measure, which is grams. So that's kind of what we're going to do here. Now, what I'd like to point out is that this is supposed to be a door. It's the mole door. And so if you wanted to go from, say, atoms to grams, you'd have to go through the mole door. And if you wanted to go from, say, grams to atoms, you'd have to go back through the mole door. And what that really is should hopefully give you an idea of is maybe potentially the number of steps that someone might have to go through to complete a problem of this nature. So I guess the easiest way for me to try to go through this or to show you would be to kind of do a couple of these examples that are left in your notes. So let's do that then. Before I go and do that, does anybody have any questions? Cool. Here we go. So in this problem here, we have a very large number of atoms. We have 1.26 times 10 to the 23rd atoms of germanium. Germanium is Ge, and we're supposed to convert it to grams of germanium. So those are the two things that we're going to do. Just like we did yesterday, I'm going to take my given information, which in this case is 1.26 times 10 to the 23rd atoms of germanium, and put it over 1. Now, I'm going to go back up to that graphic for a second. So just kind of keep with me. I'm starting with atoms here, and the problem wants me to find grams here, which means I have to go through moles here. Okay? So what that says to me in my head, which is sometimes a strange place to be, is that I'm going to go from atoms to moles to grams. So really, we're going to go from atoms to moles to mass or to grams. So I'm going to put mass up here. Okay. Now, in order to do these problems, we need to have a conversion factor, or in this case, we need to have 2 of them. So I'm going to go ahead and identify those now. So I'm going to say that my conversion factor between atoms, that's not enough room, that's silly. Atoms of germanium and moles of germanium is a very similar one to what we had up above. We said that 1 mole is always going to be equal to 6.02 times 10 to the 23rd atoms of anything. In this case, it happens to be germanium. The other conversion factor we're looking for is the relationship between mass, so grams of germanium, and moles of germanium. And like we just kind of talked about a minute or two ago, we said that 1 mole of anything is equal to its average atomic mass in the periodic table. So you might want to get out your handy-dandy periodic table and locate germanium, which happens to be, I think, element number 32. Yeah, it's like I've done this before. So element number 32 in the periodic table has a mass of 2.61 grams. So now what I'm going to do is I'm going to take my conversion factors and set them up or use them in such a way that the units cancel out. So what are you doing? You're hiding? Okay. Cool. All right. So if I have atoms on top, I need to make sure that I have atoms on the bottom. And that's going to be the unit germanium. And if I'm going to go to moles, because that's kind of what I've dictated here, I'm going to put moles of germanium on the top. And so I'm going to use the relationship that says 1 mole is equal to 6.02 times 10 to the 23rd atoms of germanium. And then I'm not done there, because I still need to get to grams, so I need to cancel out moles. So I'm going to put moles on the bottom. So I'm going to put moles of germanium on the bottom, and I'm going to put grams of germanium on the top. And when I do that, I'm going to use the relationship that I found in the periodic table that says 72.61 grams of germanium is equal to 1 mole of germanium. And now I'm going to go ahead and get out my handy-dandy calculator. And I'm going to calculate this straight through. So in this problem, I'm going to take the 1.26 times 10 to the 23rd times 72.61. And then I'm going to divide that whole thing by the 6.02 times 10 to the 23rd. And I get an answer somewhere in the ballpark of I'm going to do this way. 15.19744,186. Now the next thing that I need to do is assess the number of significant figures that I have to report in my answer. And so I'm going to draw that arrow for my given number, and I'm going to count 1, 2, 3, and that's 3 sig figs. I'm then going to draw an arrow to the first non-zero digit of my answer, and then count 1, 2, 3. And then I'm going to draw a line after that, and I'm going to see that that 9 rounds that 1 up. So my final answer here is going to be 15.2 grams of germanium. Gram hands. Thank you for playing along. All right. Questions about this so far? It's basically just like we did yesterday, except we added another step. So, here's what we're going to do. We got one more example. And I'm going to kind of start it a little bit, and then we'll talk about it, and then you'll have some time to try it and beat me, okay? Or you could try to beat me right now. I don't know. But anyway, here's what's going to happen. Here I'm looking at converting 35.2 grams of scandium, which is Sc, to atoms of scandium. And just like I've always done, I'm going to take my given, which is the I'll do it on here. 35.2 grams of scandium and put that over 1. Now, I'm going grams of scandium to atoms of scandium. So I'm going to go back up and I'm going to look at this, at that door situation again. So give me a second. So I'm going to scroll back up and I'm going to see that I have grams, right? So here I have, I'm going to use triangles this time. So grams, and it's asking me to find atoms. And it means it's telling me that I got to go through moles, and I'm going to make a diamond. Okay. So now that tells me that I have to go through that mole step again. So it really tells me that I'm going to go grams or mass, depending on how you feel about it, to moles, to, in this case, it's going to be atoms. Okay, and that's what I'm going to give you, and then I'm going to give you a little bit of time to try to work that one out. So you try to work that one out, and then we'll come back together and convene and see what our answer is. So ready, set, work that one out now. Okay, so for those of you that are working that out or almost done working that out, hopefully you're in this general ballpark right here. Hopefully what you've got is you found that the relationship between mass of scandium and moles of scandium, found that average atomic mass in the periodic table to be 44.96 grams of scandium is equal to 1 mole. You then converted moles of scandium to atoms of scandium, and hopefully you found that relationship to be 6.02 times 10 to the 23rd atoms of scandium equals 1 mole of scandium. Multiply straight across and divide. Get an answer. And I needed to do sig figs yet, so oops, I don't know what that is. So this would be 1, 2, 3 sig figs. So I'm going to draw my arrow and count 1, 2, 3. That 3 does not round the 1 up, so my answer has to be 4.71 times 10 to the 23rd atoms of scandium. Okay. Now, for some people, that door representation works really, really well. For others people, like me, it doesn't. I don't understand how that works in my head for some reason. But what I've done, what I also generally tend to do is do something that I refer to as the mole flow chart, which looks like that. But I'm going to put it in the notes and kind of try to explain it. So, like, if you have mass of something, and that would be in grams, and then we have moles something, which is moles, and then we might have atoms of something, which is simply atoms, right? So if I'm going to go from mass to moles, I can also go moles to atoms, like so. And if I'm going to go atoms to moles, I can also go moles to atoms, or moles to mass, like so. And so the other thing that I like to do when I think about these things is that if I'm going from moles to atoms or atoms to moles, I need to remember that the relationship is 1 mole is 1 mole of anything is equal to 6.02 times 10 to the 23rd of those anythings, which in this case would be atoms. And mass, right, is going to be the average atomic mass would be equal to 1 mole of that particular substance. So that's just another way to look at it. And the way that I use that is when I'm given a problem, like if the problem says, hey, you're starting with atoms and you're going to moles, what I generally do is I generally put my finger on atoms and put my finger on the ending unit, and I look at it and I say, that's 1 step. Atoms to moles is 1 step, right? If the problem says I have atoms and I want grams, if I put my finger on atoms and put my finger on mass or grams, that's 2 steps. Does that make sense? So whatever you're given as your starting unit, I usually put my 1 finger on it, and then my ending unit, I put my other finger on it. It tells me how much work I have to do. That's how my head works. So if you look at your worksheet, which I got to go grab my worksheet. Your homework is going to be worksheet number 4, which you'll have the vast majority of hour to work on in class and probably finish. But if you're looking at something like number 2 on your worksheet, right? Number 2 says convert 3.25 moles of copper to atoms. So I'm going to put a finger over moles and a finger over atoms and see that I'm just going to go moles directly to atoms, and that's all I need to do. Does that make some sense? But if I look at question number 3 on here, says convert 25.98 grams of tin to atoms. So I would put my finger on grams and my other finger on atoms and see that I have to go mass to moles to atoms. Hopefully that might make a little bit of sense. Any questions about these last few problems that we did in class today?